to talk about lesson 4.4, and kind of ties into 4.5 as well. But what we wanted to do in our investigations were determine, are there shortcuts to help us prove that two triangles are congruent to one another, instead of having to go through the process of measuring every single side and comparing it to the corresponding triangle, and then also measuring every single angle and comparing it to the corresponding triangle to prove that yes, all three sides and all three angles are congruent to one another. So if we could shortcut that, that'd save us a lot of work. So this slide right here, you may want to pause to copy down, because when we talk about side, 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 and side, angle, side, and angle, side, angle, and side, angle, angle, and side, side, angle, and angle, 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 it helps to know what we're talking about as far as the order of things. Side, 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 and angle, angle, angle are obviously pretty easy because the three sides or the three angles. But when we talk about side, angle, side versus angle, side, angle versus side, angle, angle, and side, side, angle, it kind of helps to know what more specifically we want to discuss. All right, so in lesson 4.4, this was the first investigation, the first three investigations we did. We determined that yes, there are two shortcuts we can use. We can use the side, side, side congruence conjecture. So if three sides of one triangle are congruent to the three sides of another triangle, then yes, everything about those triangles are congruent. So the three angles, the corresponding angles. We also determined side, angle, side congruence conjecture. So if two sides and then the angle in between them are congruent to two sides and the angle in between those two sides of a second triangle, then the two triangles are congruent to each other. So the other parts would also be congruent. However, though, side, side, angle cannot be used as a shortcut. We were able to show, with a little bit of difficulty, how there are two possibilities of measurements if I know two sides and the non-included angle are congruent to two sides and the non-included angle of another triangle. So, a quick little shortcut to help you remember not to use side, side, angle is read the word backwards. Notice it makes a bad word, an inappropriate word to be using in school. So, that should be a reminder of, ooh, bad word, can't use it. So don't use it as a congruence conjecture because it does not work. Something I learned when I was in high school geometry has always stuck with me, so maybe that'll help stick with you as well. Let's take a look at a couple of scenarios of how we would use these conjectures to prove or not prove triangle congruency. All right, so the first two examples I have here are asking you to prove that one triangle is congruent to another triangle, or is it? So which conjecture tells you it's congruent versus which one, or if it does or doesn't. Now, when you're looking at this, you do want to make sure you're keeping aware of the order of the letters. So L-U-Z and A-I-D, or I-D-A, I mean. So L-U-Z, we're kind of going in this area. That means L-U needs to be congruent to I-D. All right, so yes, that's congruent. Then we notice that LZ, so first and third, is 22, so that needs to be congruent to IA. So yes, it's congruent. Angle L is 65 degrees, and that needs to be congruent to angle I. So yes, those two angles are congruent. So the corresponding parts are matching up based upon the order of the name of the triangle. So we notice that it's side, angle, side that is proving our conjecture. Let me write that up here so you can prove it. So when it asks you which conjecture tells you that one triangle is congruent to another triangle, you just need to put the abbreviation. So side, angle, side is just fine in that case. Let's take a look at our second triangle. So COT and NPA. So COT and NPA. Now, according to the picture, CO or OC, however you want to put it, is congruent to NA. I want to change the color to make it show up a little bit easier here on the black, hopefully. Let's go ahead and use white. All right, so we know that CO is congruent, according to the picture, to NA. And let's make sure those numbers match up, or sorry, those letters match up with our picture. Unfortunately, I have to go back to a different color, so white may not correspond with us here. Oops. Try again. There we go. CO is the first two, and NA is the first and the third. They're not in order. So COT has to go this way, NPA goes this way. So according to the labeling, CO is supposed to be congruent to NP, and we can tell by the picture that it's not. So actually, what we would say in this case then is that congruency cannot be determined. So if you're trying to prove that triangles are congruent to one another and you can't, then you would say it cannot be determined. And that's going to happen sometimes. It's just a matter of fact. So don't get fooled by thinking, oh look, side angle side, side angle side. Look at the order that it's going in. Let's take a look at another example. Now we're going to try and use our conjectures to find the corresponding parts. And again, the order is what's important here. So, third time's the charm. I'm choosing a color that will show up. Let's see if light blue will show up. A and T. So A and T is going this way. So what's going to match up with AN? Well, the two-sided figure here, so there's either LF or it can be known as FL. So we have to follow the other order then. So then the next one would be NT, and NT has 3 congruent markings, so that means LE would be the next one. So our order for naming it to make sure that it matches up would be, we need to go in order of FL to E. So FLE is the name of the triangle that is congruent to triangle ANT. Again, the order is what's important on that. So yes, you can call that triangle a number of different names, ELF, FEL, FLE, but in order to show congruency, we need to make sure that the parts match up. So that now, looking at the sentence, I could say that angle A is congruent to angle F, and angle N is congruent to angle L, and angle E is congruent to the other angle E. Or sorry, that's supposed to be a T. My marker is not cooperating. So angle T is congruent to angle E. So that's why the order is important there. All right, so let's try and match it up for triangle GIT to the other corresponding triangle. So GI, we're going to go from 3 to 2. So going from 3 to 2 markings, we have AIN. I don't know why it's wanting to mark everything together. So triangle AIN would be our final answer. And those both use side, side, side to prove it. So if you're asked to justify the naming of the triangle, you can say that the conjecture side, side, side proved that for you. Now looking at our next one, all right, we have 2 triangles that are on top of each other. Also, could be a kite that has been cut in half. So we know that this is congruent to this side because of markings, and we know that this is congruent to each other because of the markings, and then the 2 angles have been bisected by that diagonal. So if we say OSA is congruent, then we could say TSA. And notice that the order I went in had to include that angle S there in the middle to prove that side, those 2 angles are congruent. And also, the side SA is congruent on both of them because it's a part of both triangles. So SA needed to end it up. So that's why we didn't say STA or anything like that. So now our congruent sides, OS congruent to TS and SA congruent to SA, those are showing us that these are the congruent triangles. And we're using side angle side to help us prove that. And that's pretty much what we're going to be doing with our triangles, using our conjectures to prove if triangles are congruent to one another. And if we know that there are conjectures there, how can we name the triangle appropriately to be congruent?